Welcome to The Explainer. Today we're diving into something that's happening inside your body right now, one of its most critical behind-the-scenes jobs, maintaining a perfect chemical balance. We're going to explore that delicate dance between acids and bases, and then we'll uncover a really clever diagnostic tool called the anion gap. So let's start with a question. What could pneumonia, a bad anxiety attack, and a bout of diarrhea possibly have in common? I know, it seems like a totally random list, right? But believe it or not, every single one of these can knock your body's internal chemistry way off balance. They can disrupt the very foundation of what keeps you alive. And today, we're going to figure out how clinicians track down exactly what's gone wrong. All right, here's the game plan. First, we'll tackle the pH balancing act itself. Then, we'll look at this perfect golden ratio the body is obsessed with maintaining. After that, we'll see what happens when that scale tips. And finally, we'll pull back the curtain on a key diagnostic tool that helps solve the medical mystery. So let's start with this idea of a balancing act. I want you to picture your body as a tightrope walker, high above everything. Just to stay alive, it has to be in this state of perfect balance, constantly making these tiny, microscopic adjustments. Well, in our internal chemistry, that crucial balance is measured by something we call pH. Now, pH is not just some number you forgot from high school chemistry class. It's a vital sign. Your blood has to stay in this unbelievably narrow window, between 7.35 and 7.45. If it moves even a little bit outside of that, it's a huge deal. And here's the really wild part. The scale is logarithmic. That means a seemingly small drop of 1 point, say from 7.4 to 6.4, is actually a 10-fold increase in acidity. That's a massive chemical shift, and your body will do anything to stop it. So how on earth does your body manage this incredible tightrope walk? Well, it's got a two-part team. On one side, you've got the lungs. They're the sprinters, the fast responders. They can make really quick adjustments just by changing how fast you breathe and how much carbon dioxide you blow off. Then, on the other side, you've got the kidneys. They're the marathon runners, slow, steady, and making these deliberate, long-term changes by managing a substance called bicarbonate. They're a true dynamic duo. And that brings us to the perfect ratio. You see, this whole balance thing, it's not random. It all boils down to a very specific, absolutely critical number that the lungs and kidneys are working together, nonstop, to maintain. 20-1. That's it. That's the body's golden ratio. To keep your pH sitting pretty at that perfect 7.4, your body has to maintain exactly 20 parts of bicarbonate, that's the base that the kidneys manage, for every 1 part of carbonic acid, which is directly tied to the carbon dioxide your lungs control. And this really just nails it down perfectly. I want you to think of it like a seesaw. As long as you've got that 20-1 weight distribution, the seesaw stays perfectly level. Your body is happy, it's in balance, and you're healthy. But what happens when that seesaw gets tilted? Because life happens, right? Illness can come along and knock everything off balance. There are 4 main ways this can go wrong. But thankfully, the body has some built-in countermeasures to try and level things back out. This chart shows that dynamic teamwork perfectly. Just look at the pattern here. If the problem starts with the lungs, let's say pneumonia makes you hold on to acidic CO2, the kidneys jump in to compensate. And the reverse is true. If you have a metabolic issue, like losing base from diarrhea, the lungs try to fix it by breathing faster to blow off more acid. It's this constant, incredible dance of compensation. But, sometimes that compensation just isn't enough, and doctors have to dig a little deeper. This is especially true when it comes to metabolic acidosis, because there are so many potential causes. To find the right one, they need more clues. And that brings us to a brilliant little tool for these clinical detectives, the anion gap. Okay, so on a chemical level, your body is always electrically neutral. The positives have to balance the negatives. But here's the thing. A standard blood test doesn't measure every single charged particle in your system. It only looks at the major players. The anion gap is just a simple calculation that looks for evidence of unmeasured negative ions, sort of like chemical ghosts hiding in the background. It's not a real physical gap, but a calculated clue that shows us what we can't see directly. And the math itself is surprisingly simple. You just take the main positive ion that we measure, sodium, and from that you subtract the 2 main negative ions we measure, chloride and bicarbonate. That's it. It's a simple 3-step process using numbers they already have from a standard lab test to uncover a hidden piece of the diagnostic puzzle. So, what's the normal result? What are they looking for? typically a number somewhere between 7 and 16. If a patient's number is in that window, the gap is considered normal. But if that number is higher, it screams to the doctor that something is adding extra unmeasured acid to the blood. So what do these clues actually look like? Let's break down what a high or a low gap tells a clinician. This is really where that simple calculation becomes a powerful diagnostic weapon. An elevated anion gap, this is the big one. It's the most common and the most clinically important finding. It's a huge red flag that there are extra, unmeasured acids floating around in the blood. And this immediately points the doctor toward a very specific list of suspects, things like kidney failure, ketoacidosis from out-of-control diabetes, or even certain types of poisonings. Now, a low anion gap is way less common, but it's not meaningless. Remember those unmeasured negative ions we were talking about? Well, it turns out the main one is a protein called albumin. So if your albumin levels are low, that gap is naturally going to shrink. It provides its own unique set of clues, pointing doctors in a totally different diagnostic direction. So here's the real takeaway, the bottom line. A patient comes in with metabolic acidosis, a super broad problem. But by using this one simple calculation, a doctor can take dozens of potential causes and funnel them down to just a handful. It transforms a vague problem into a focused, targeted investigation. So from the pH scale to that 20-to-1 ratio, all the way to the anion gap, it's all part of your body's amazing, constant, and totally silent effort to maintain that perfect equilibrium. It's a tightrope walk that's happening inside you right now, and it never ever ends. It really makes you appreciate all the systems working around the clock just to keep everything in balance. Thanks for joining this explainer.